Okay. Let's start with question number 5. We have a 50 kg woman that, so the weight 50 kg, a single IV dose with antibacterial drug with a dose level of 6 milligram per kg. Again, directly we correct for the dose to be with the unit of mass only. So this will be 6 multiplied to 50, as this is kg and this is milligram per kg, and this would be my hand keep touching the panel. That's why we keep minimizing and maximizing this in the unit of milligram, okay, according to this. Then the concentration of the drug CB was determined, the plasma fraction of each sample, and the following data were determined. It's here the time in unit of hour and concentration in unit of microgram per milliliter. And again, as question 4, you have the time, you have the time in the unit of hours, you have concentration in microgram per milliliter. If you draw on rectilinear profile the concentrations that you have versus time, you have a exponential, mono-exponential profile. If you have it on semilog, you'll have this profile, and then you need to have it either on log term or ln term on rectilinear graph to determine the linear regression equation, okay, and then we use it to determine whatever that we need, as we did in question number 4. So here we have the equation. I will write it here to start with whatever is needed, okay? So the linear regression equation of log CB versus time, it's y equal to minus 0.0074. One second, let me just, yes, plus 0.9332, okay? Again, this is the linear equation. From that, well, we have x here, by the way. Okay, from that, you know that this is our slope, okay, and this is our y-intercept. And the question is, you find that it's asking about VDK, half-life of this drug, okay, and I will write you the final answers because we already talked about the way to determine this. So let's go with the final answers of each one of them. But just to remind you, we use this to determine K. And from K we can determine also the elimination half-life, and from this we can determine CB node, and from CB node you can determine what? VD. Okay, so let's write our answers here. You will have K that is equal to 0.1704 hour minus 1, and we will have half-life, oops, it's not writing anymore, why? Okay, equals to, we have a jamming problem, equals to 406 hour, which is 4 hours. Okay, and we have volume of distribution after you determine CB node, which will be equal to 857 start to, I think the iPad is hot a bit, so that's why it's doing this. Per milliliter, okay. We just stop this. And then accordingly, we can determine VD, which is equal to 35.01 liter, okay? So those are the required parameters of the first part of the question, which is A here, okay? The antibacterial agent is not effective at plasma concentration less than 2 microgram per milliliter, okay? And what is the duration of activity for this drug? So this question is very important question, and let's sketch what the question needs and what it's asking us about, okay? So let's draw it or sketch it, in other words. So it's asking us about, or telling us that this drug, if we are having CB versus time on rectilinear graph, this is our profile, okay? The antibacterial agent is not effective at plasma concentration less than 2 microgram per milliliter. So it's giving us the concentration, okay? At which below that concentration the drug is not effective, which is, in other words, this is the minimum effective concentration of that antibacterial, right, agent. It's asking about the duration of action. If below this the drug is not effective, it means that at higher concentration the drug is effective. So in other words, we need to determine this duration of action, okay? It's the same as the question that we asked question number 4, but I'm asking about it differently, okay? So let's go. To determine this duration of action, you need to use CB at certain time equal CB node K with time, right? You have to determine this, which is your duration of action. Okay, we have this as 2 microgram per milliliter. We have this as X node over VD, which was determined here, 8.57 microgram per milliliter, multiplied with E. We have this, yes, we have this, which is determined here, 0.1704, multiplied with the time that is needed, okay? The time when you do the calculation, which is the same as duration of action, equals to 8.5 hours, okay? The last one, which is, no, not the last one. How long would it take for 99.9% of the drug to be eliminated? Okay, so in this question, it's asking you about the time, okay, but not to give you certain concentration, but to give you certain percentage of elimination, okay? So we talked about the fraction and percentage of elimination when we did the explanation of this chapter. So we have something called fraction remained, and we have something called fraction eliminated, okay? So it depends on whatever that is in the question. You need to make sure to use the right equation. This equals to 1 minus ek with time, and this is equal 1 to the fraction, sorry, we have mistake here, okay? And we have this that is equal to 1 minus e minus k time, or 1 minus fraction remained, right? We know this already. Okay, and you can go back to the lecture to know how we get those two equations. Okay. And I told you all the time just to make sure if the question is giving you fraction or percentage or asking you about fraction or percentage, okay? So if the drug, as the question mentioned, how long would it take for 99.9% of the drug to be eliminated? Then this is the percentage of the drug eliminated, right? If I want to determine the fraction or to convert it to a fraction, this would be equal to 0.999 of the drug eliminated. Okay, so I need the time at which this fraction was eliminated. Then I need to use this, okay, equation by saying the fraction of the drug eliminated, this is eliminated, equals to 1 minus k with time. Okay, I need to determine the time. Okay, do we have this? Yes, which is constant, and this that is equal to 0.999. Okay, then the time will be, if you rearrange the equation to for 99.9% of the drug elimination, equals to 40.5 hours. Okay, and this is what C. Yes, it's C. So this is B, and this is C. Okay, then for D is asking us if the dose of the antibiotic was doubled. Okay, what would be the increase of the duration of activity? Okay, if you remember in this part of the question, it gave us the minimum effective concentration, but we were taking a dose of 300, right? Yes, 300 milligram. So if this, our duration, which is 8.5, if we were given a dose of 300 milligram, what would be the increase in the duration of action if I doubled this dose? So I'm doubling this dose, okay, is my new dose. Let's call it X02. Okay, what would be the new duration of activity or duration of action? And if I know this, what would be the increase on this duration of action? So if the dose is different, then we know that the CB node would be using the second dose over VD, which is constant. So either we say that the dose is doubled, which is here, equal to multiplied with 300 over VD that we already have, which is 35 liter, okay? Or, which will give you your new CB node, which is 17.4 microgram per milliliter. This is your new CB node. Or you just, without doing that, because the only change here is in the dose, we can say that CB CB2 equals CB1, right? CB naught 1, which will be equal to the multiplication of 2 with your old CB naught, okay? Which was 2 multiplied to 8.57, which will be equal again 17.4 microgram per milliliter. Okay, now it's asking us about the change in the duration of action. So what we need to do is CB at certain time equals CB naught, which is our CB naught, new CB naught, minus K with time. This won't be changing. It's your minimum effective concentration for the antibiotic, which is not changing, which is 2 microgram per milliliter equals your new CB naught, which is microgram per milliliter, multiplied with this, which is constant, 704, multiplied with the time that I need to know, which is the new duration of action. Play around with your equation, you'll find that the time equals to 12.6 hours. Let's call it 2, or the duration of action with the double the dose, when we double the dose. Okay, did we finish the question? No. The question is asking about the increase or the change in the duration of action. Okay, so this would be whatever that we have right now, which is the new, minus whatever we had before. This would give us 4.06 hours. So this is the answer. This is the change or increase in the duration of action or activity. Okay, by this, I think we finish this question. Let's just focus. Yes, so I will stop here and continue the last question in